Alright, we have one more topic on the derivative problems associated with trigonometric functions. Let's consider some tangency problem. Again, what we are looking for is the slope point equation of a line. And by the way, if you prefer this form, these two are equivalent. So if you prefer the latter form, go ahead and use it. My preference is this one. You can easily see the equivalence. Flip this y0 to the other side, we get that, and vice versa. Now, given x0, I can find out y0 by plugging in. And then the slope, well, that's a key point. y0 in this case, I have to plug in x equal to pi over 4. So this is my function. Let's expand the font once more, and then plugging in pi over 4 here. Pi over 4 here. And then pi over 4 here. Okay, alright. Do you remember all these trig values? Sine of pi over 4, what is it? Look up the table or punch the calculator if necessary. It is 1 over square root of 2, or equivalently speaking, square root of 2 over 2. 1 over square root of 2. And then tangent of pi over 4. Tangent is sine over cosine, and they're the same, so tangent is just 1. If you rationalize, you're going to see that this is square root of 2 over 2. Square root of 2 over 2. Yeah, okay, that looks better. We have just square root of 2. Okay, why not is square root of 2. So we're down to this, y equals to slope m, which we don't know, x minus pi over 4 plus square root of 2. If we find this m, then we are through. So we have a point, and then x0, y0, okay, and then we want to find out the slope. The slope of the tangent line is the derivative evaluated at the point. So let's find the derivative function. How do I do that? Well, here we go. And then let's use the quotient rule. So denominator squared, we need a little bit bigger font. And then what do we have? U prime v u v prime. Okay, alright. The derivative of the numerator. Sine of x plus cosine of x. Sine of x becomes cosine of x, and cosine of x becomes negative sine of x. So that's the derivative. Now how about the denominator? Derivative of tangent is, look up if you don't remember, secant squared x. So we have the derivative function. Now, let's calculate the slope m. So copy and paste this entire thing. Oh, too small, a bit bigger font. That's a bit too big. Alright, that's about right. And then this is pi over 4. And then sine of pi over 4. And tangent of pi over 4. Okay, all right. What's this computation? Let's see, cosine of pi over 4, what is that? That's square root of 2 over 2. Over 2. And then sine of pi over 4, that's also square root of 2 over 2. So what do we have here? This entire thing is 0. Square root of 2 minus 2. Square root of 2 over 2 minus square root of 2 over 2. And then this is actually times 1, but this entire thing is 0. So no problem there. Now here, square root of 2 over 2. And then this one is plus square root of 2 over 2. And then this one here, square root of 2 over 2. Oh no, this is secant. So it's the reciprocal, 2 over square root of 2. But square both, 4 over 2. 4 over 2, what is it? 4 over 2 is 2. And then tangent of pi over 4, 1 squared. So I don't really have to worry about the denominator. 1 squared is 1. So what is this? This entire thing is 0, so it just goes out. Denominator, that just goes out. Square root of 2 over 2 plus square root of 2 over 2. So that's minus square root of 2 times 2. So negative 2 square root of 2. That's my slope m, if my mental math is right. So plugging in this value, negative square root of 2 over 2, right here, I'm going to get the answer. Let's see, is this right? Let's check. Plug in pi over 4 to your computation. I get y naught is square root of 2 over 2. Using quotient rule, we can take the derivative, okay? Dot, 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 here the derivative, dot, 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 here the derivative. Blue numerator, red denominator. Put numbers in and do your computation. I get negative 2 over square root of 2 square. Yeah, okay, the same thing we did before. So, we have the equation of the tangent line. Is this correct? Let's run this program and let's check. Yes, indeed, it's a tangent line. So, what did you do here? Slope point equation, either this way or that way. X0 is given, find y0. How do I find the slope? We need to take the derivative. We need some differentiation rule here, in this case quotient rule, and then plug in the numbers and calculate. You can use handheld calculator or something. And then, after appropriate simplification, put all those numbers in, and then you have a right equation of the tangent line. Let's see, do we have time for it? No, not really. This one requires chain rule, so let's not worry about that. So we went through a lot of typical problems here, some limits, some derivatives, and some tangency, all about trigonometric functions. Of course, there are many more, but you can find those in homework problem sets.